Hello, Year 7. Today we're doing about compounds, and today's lesson is just here, so let's go in there. I would make sure you've got your periodic table ready, just in case you need it, and we're going to go straight into the PowerPoint. So let's have a look then. Oh, compounds. I would recommend that you pause the video and try and answer those 3 questions first. Hopefully we remember this from before. If not, then a bit of revision doesn't hurt. Okay, let's have a look at this then. So, we did elements last lesson. Materials composed of one type of atom, and here are some examples. Okay, oxygen, gold, hydrogen, helium, aluminium. Notice they have given you the symbol next to it, and even something that's got a little 2 still counts. Okay, so hydrogen, even though it's got 2 of them stuck together, it is the same atoms, they are identical. Okay, compounds. These materials are composed of 2 or more types of atom that are chemically joined together. Now that is really important, that last bit that's not written there. And we'll get on to why that's important later. But here's some examples. We've got sand as a compound, salt, just table salt, wood, steel, plastic, water, which is H2O. Notice that H is hydrogen and O is oxygen, and because you've got these 2 together, they are 2 different atoms, so that makes you a compound. Okay. Here are the lesson objectives. If you'd like to have a read through them, just pause the video. Right. Compounds are 2 or more elements chemically joined together. This is a very important definition, and if you're asked what a compound is, you need to sort of say this exactly. This is the definition. Don't change the words, just remember it and repeat it. Now, if you look here on the left, I've got carbon and I've got oxygen. These are not joined together. You see there's space in the middle. So this carbon is by itself. This carbon is an element. This oxygen is joined to another oxygen, but because they are the same atom, okay, and there is nothing else joined to this, this is still an element. So we have 2 elements. This would be cast as a mixture if I mixed them both together in the same container, because they're not joined. I could separate them again. Now if you look over on the right here, we have got carbon dioxide. That is 1 carbon atom joined to 2 oxygen atoms. So we should now be thinking about, well, this is a compound, and it's a compound specifically because you have got 2 different atoms that are joined. And we usually either stick them together like this oxygen, or we write a little stick, like a little bar, in between them to show that they are chemically joined together. So, compounds. The properties of elements can change when they react together to form a compound. So, if I had 2 different things, they may have certain properties. If I reacted them together to make a compound, they would probably have different properties. Now, atoms are rearranged in a chemical reaction. That is really quite important. If you are asked, how do you know that a chemical reaction has happened, given 2 diagrams, and the atoms were different, you would say they were rearranged. That's the easiest way to spot it. Obviously, in real life, you would not be able to see atoms, but in an exam question, they might ask you something like that. So the 2 reactants are the things that will react together, and then they form something else, and that is called the product. Okay. So if you look here, if you were asked the question, how can you tell a chemical reaction has happened? Well, you look at the reactants here, okay, and then you look at the products, and you will go, the atoms have rearranged themselves. On this side, only the black circles, which are iron, are attached to other iron atoms. and the sulfur circles, which are yellow, are only attached to other sulfur circles. Okay. On the right hand side where the products are, you can see the atoms have rearranged themselves. Now an iron atom is attached to a sulfur atom, which is attached to an iron atom. So that rearrangement shows you that a reaction has taken place. Now, unfortunately, this is a practical. Now, I would like you to do a bit of Googling though. And when we get back to school, we'll catch up on some of the practicals that we've missed, so don't worry about that. So draw a particle diagram to show the reaction of iron and sulfur, which is just what was on the slide before. Now, list the properties of iron, list the properties of sulfur, and list the properties of iron sulfide. I would like you to just go onto Google and write, what are the properties of iron? What are the properties of sulfur? And then, what are the properties of iron sulfide? Wikipedia is a good place to look at this, but there will be probably plenty of videos or links that you can check on. I'll let you choose which one to do, because I'd like you to try and research this for yourself. And again, challenge task if you're feeling up for it. Can you write a word equation for this reaction? And can you write a symbol equation for this reaction? Again, we haven't done anything like that before, so I'll let you use Google to see if you can find it. Now, that's pretty much the end of the lesson. The only thing I would like us to do now is open up this worksheet. I'm going to quickly take you through it, because you should remember this. We've seen this worksheet before. Now, what I'm going to do is I'm just going to make sure that we understand a few things. I don't actually want you to colour the things in. If you would like to, you can, if that helps you. Now, if you look, these oxygen atoms, there is only oxygen atoms in this box. Because there is only one type of atom in this box, this must be an element. Okay? Again, with this hydrogen, this box only has hydrogen atoms in, so again, this is an element. It's a different element, but it's still an element. Now if we look at this bottom one, these are all separate, right? But let's look at, they all look the same, don't they? So let's just look at one of these. Well, that's oxygen, so I'm going to draw it up here. So far I've got this, which is, I'm going to change the colour to draw the hydrogens, just to make it easy to spot. We draw water like this because this is actually what a water molecule shape looks like, and the way I remember is they look like little Mickey Mouses. Okay, the big O is the face, the little H's are the ears. So you can see that, well, this is oxygen, and this is hydrogen. Right? Because these are touching, that means it is joined together. Now, because you have got two different atoms joined together, this is a compound. And if you look in the box, there is only those molecules there. There is only H2O in this box. Each one of them is one oxygen and two hydrogens. So this would be a pure compound. Now let's go down a little bit. Sorry about that, went a bit too far. Right. Well, we should be able to find the names of these using our periodic table. And if you look at this, notice that you've got two different types of elements here. You've got this one. Sorry, two different types of atom here. You've got this one and you've got this one. But notice that none of them are joined together. You can separate each one of these. Because you can separate each one of these things here, right? This is a mixture. None of them are joined together, so this is not a compound. Because you've got lots of different things next to each other, it's not an element. Sorry, I should say lots of different atoms next to each other, it's not an element. And because they are not joined, that makes it a mixture. Now let's have a look at this. This is methane. the formula is CH4. I'm going to draw methane, and we're going to have a look at why that's the case. So there's the carbon. Okay, and I'll do the hydrogens in green. I know I did them in black, sorry, in blue. I know I did them in black before, so I should have really done it the other way around, but it doesn't matter too much. There's my hydrogens. Well, how many carbons do I have? Well, I just have one carbon. We don't write C1 normally, but you could do that. Okay. And how many hydrogens do we have? We have 1, 2, 3, 4. Ah. H4 means 4 hydrogens. So that is why the formula for this is CH4. Well, hopefully we realise that this is a compound. You've got carbon atoms, which is the first element, and you've got hydrogen atoms, which is the second element. They are joined together. You can see they are joined together. So because you have got two different elements, or two different atoms that are joined together, you have got a compound. And because all of these are the same, okay, it's not a mixture. So this is a pure compound. So after you've done that first task I asked you to do, which was the Googling bit, and then you've just listened to this and like walked through this, because this is a task we've done before. You don't need to redo it. If you would like to write some of the stuff down that I've mentioned, and that is fine as well. Okay, could you please email me your work, and then that's all for today.